Alright, good day guys. We'll be talking about one-sided limits, and it's something simple. I'm explaining the fundamental, that is the foundation for today's simple term. Now let's assume you have normal limits, limiting of a particular function as it tends to c negative of a function x. You know this x has a value here, which we just let it be c, which is equals to l, an output value also. Then also again, let's say you have limiting a particular value as it tends to c positive of a function x, which is also equals to l. Now under one-sided limits we have two things. That two things is what we call the left hand rule and the right hand rule, or you say the left hand limit and the right hand limit. Now this is called the left hand limit and this is called the right hand limit. Now there's something, just two important things that I need to take note of under this left hand limit is that first of all, it is starting from the left. Are you with me? And you have to take note that this value of x, let's say you are being given 2 here. So far it is starting from the left hand limit, it must be less than the value you are being given. Now when we take example, you understand what I'm trying to explain here. Now if x is equals to 2, so far it is a left hand limit. Are you get what I'm saying? It cannot be greater than 2, neither can it be equal to 2. It has to be less than 2. Let's say we are using 2. So like I said, less than. So so far like I've said less than for this is like an inverse of it. This will be greater than. Are you get what I'm saying? So this one is greater than, this one is less than. And also again, there's one thing important under a one-sided limit rule is that let's say you have limiting a particular function as it tends to normal c, your normal function, which is equals to l. You can use it to prove this function if the function exists or DNE. That is, DNE means does not exist. Now look at, let's use one example just to back up our explanation. Now if you are to look at this, it says discuss the limits of the function, of this function s. This is a piecewise function. Let's say at c equals to 2, just like I said, I'll be using 2 to explain. Now, like I told you guys, we have to first of all limit, limiting as s tends to, now here it won't be c anymore, it will be 2 negative of the function x. Now you have to check that. That is why I said less than is very important rule here. Now which value is less than 2 here? To obey the law of limit, piecewise function, you have to check out the intervals. Now x greater than or equal to 2 cannot be less than 2, impossible. So therefore x less than 2 here automatically obeys the law, which is the function x we are going to be using to solve this limit is going to be 2x minus 4, and that will be 2x minus 4, which will be equals to, inserting your value of 2 here, that will be what, 2 times 2, 4 minus 4, that will give us 0. And limiting as s tends to 2 positive. And since it's 2 positive, I told you guys that greater than, though that is why I gave you the 2 rule, at least for the primary foundation. Greater than, so far it is greater than 2, and this obeys the law, greater than or equals to 2. That is a closed limit of 2, then till infinity. Something like this. Let's just put it that way. Now from 2 then till infinity. So far it is equals to 2 and greater than 2, our function x here will be s squared. And that will be equals to 4, 2 squared 4. And if you are to automatically check out that does this limit exist, what will be your answer? Limiting as s tends to 2 of let's say the function x. Let's put it that way. So does this limit exist? If you say no, you are correct, simply because the left hand rule and the right hand rule are unequal. So therefore this does not exist. So this is that on today. Please try to follow up our channel for more. I go by the name Crypto Quanta.